We have seen that carboxylic acids are acidic. That's because their carboxylate ions are stabilized by resonance. Let's now see effects of substituents or groups on the acidity of carboxylic acids. Let's take butanoic acid as an example and 2-fluoro-butanoic acid as another. In order to judge, if you like, or compare acidity of these two carboxylic acids, of course, we need to look at the corresponding conjugate bases. So let's draw the conjugate base of this first carboxylic acid. So we get butanoate, and we can stabilize the butanoate or the carboxylate of butanoic acid by resonance, just like before, by taking one of the lone pairs on oxygen, making a double bond between oxygen and carbon, obviously as a result breaking the carbon-oxygen double bond. If we do this, we get another resonance form. So this is resonance stabilization, the usual resonance stabilization of carboxylate ions. Now, if you look at 2-fluoro-butanoic acid, now we can draw its conjugate base. Now we can do resonance stabilization in the same manner. So by taking one of the lone pairs on oxygen, making a double bond between oxygen and carbon again, and breaking the carbon-oxygen double bond. If we do that, we get another resonance form, which is this one, the usual resonance stabilization of carboxylate ions. But if you look at this carboxylate ion or this butanoate, it has a fluoro group on position number 2. Now this group is an electron withdrawing group by inductive effect, so which actually withdraws electrons toward itself in this carbon-fluorine bond, leaving fluorine with a negative partial charge and that carbon with a positive partial charge. So this is inductive withdrawal by the strongest electron withdrawing group in nature, in chemistry. So this is an electron withdrawing group by inductive effect. If you like, there is an additional inductive withdrawal. So this results in additional withdrawal. Now this additional inductive withdrawal results in further delocalization of electrons, further delocalization of the negative charge, and therefore stabilization of the carboxylate ion. As a result, this carboxylate is actually more stable than the butanoate itself. Therefore, 2-fluoro-butanoic acid is more acidic than butanoic acid itself. So this conjugate base, therefore, is more stable. If you like, electrons and the charge are more delocalized. This conjugate base, therefore, is more stable. When we say more stable, that's relative to the butanoate itself. If this carboxylate or 2-fluorocarboxylate or 2-fluorobutanoate is more stable than butanoate itself, therefore 2-fluorobutanoic acid is more acidic. So the difference here is the presence of an electron withdrawing group by inductive effect on the carbon chain. So the presence of electron withdrawing groups by inductive effect on carboxylic acid enhances their acidity by the additional resultant inductive withdrawal, which delocalize the charge, the negative charge, delocalize electrons, stabilizing the conjugate base, and therefore the carboxylic acid is more acidic.